So a particular form of electromagnetic radiation has a frequency of 8.11 by 10 to the 14 exponent on hertz. So question A, what is its wavelength in nanometers? And yeah, of course, the wavelength in meters. And B, to what region of the electromagnetic spectrum would you assign it? And C, what is the energy in joules of one quantum of this radiation? Okay, so it's easy. First of all, is that if you remember the light speed is going to be on the wavelength by the frequency, right? Okay. So if I clear lambda, the wavelength, passing to the left, the frequency, here is multiplying, then go to the other side, dividing, okay? We have here lambda. So the velocity, the light speed, okay, is going to be 3 by 10 to the 8 an exponent. And the frequency, okay, the frequency is going to be 8.11 by 10 to the 14 exponent, right? So lambda is going to be 3.7 by 10 to the minus 7 meters, okay? That will be the wavelength on meters. So next step is pass these meters to nanometers, okay? So 3.7 by 10 to the minus 7 meters. I know, for example, that 1 nanometer is going to be on 10 to the minus 9 meters. Oh yeah, so 3.7 by 10 to the minus 7 by 1 under the 10 to the minus 9. So this is 370. 370 nanometers. That will be lambda. Okay. These two answers are the same, but this is on meters and this is on nanometers. Okay. So if you look, let me see if I can show you. Okay. On the spectrum, the electromagnetic spectrum, right? I will search, let me see if I have here. Yeah, this one. Okay, I will show you. Just give me a second. Okay. Yeah, there it is. So, let me see. Yeah, there it is. And there it is. Okay, so this is the electromagnetic spectrum. So the wavelength is gonna be 370 nanometers, okay? So yeah, look, 370 nanometers, it's out of range from the visible spectrum, right? It's out from the visible spectrum. So if you can see the electromagnetic spectrum, 370 nanometers is on the left side from the blue color. And yeah, look at the screen, is the UV. UV here, let me see if I can write the color. Okay, this is the UV. The UV on the electromagnetic spectrum. And yeah, that will be the ultraviolet region. Okay, that is going to be the ultraviolet region. So on this example, this light with 8.11 by 10 to the 14 hertz is in the ultraviolet region. Okay. Okay, that will be question B. And question C, calculate the energy of a photon, of a quantum. Okay, so here we have the Planck's constant, 3.626 by 10 to the minus 34 by the frequency, 8.11 by 10 to the 14 exponent and that 10. So there it is. So you can use the calculator, 6.626 by the minus 34 by 8.11 by 10 to the 14 exponent. So the 14 exponent, yeah. So it's going to be 5.37 by 10 to the minus 19 joules. That will be the energy for a quantum, remember. Okay, a quantum, the particle of light is the photon. Okay, that will be the energy for a photon on this ultraviolet region on this frequency, right? And there it is. We have solved the energy exercise to the energy, lambda, and the speed of light. And that's it.